Zero Education Society, redefining excellence.
Hello everyone, this is the micro project under the subject of VLSI with VHDL with subject code 22062. First of all, we will see what is an VLSI with VHDL. In the present scenario of electronic technology, CMOS is a virtual important and basic need in the design or development of almost all products in the range from consumer to industrial and telecommunication engineering area. Functional capabilities of this technology leads to advanced very large scale integration, large density of components, high speed of operation, less area with less power dissipation. Therefore, imparting knowledge of VLSI and its tool is need of today. After studying and learning this subject, we are able to develop applications in the area of digital electronics using VLSI's design tools. Here in this project, we have designed one of the application of VLSI with VHDL, that is the FIFO memory. Title of micro project is VHDL code for 4:4 FIFO. My group members are Naik Prathamesh Ganesh, that is me, Khan Imtiaz Firoz, Khalse Mayuri Sriram. We have completed our project under the guidance of Professor S.N. Navle ma'am. The aim of the project is to develop VHDL code for 4:4 FIFO memory. Now what is an FIFO? Let us see. In every item of digital equipment, there is exchange of data between printed circuit boards, that is PCB. Intermediate storage or buffering always is necessary when data arriving at the receiving PCB at a high rate or in batches, but are processed slowly or irregularly. A FIFO is a special type of buffer. The name FIFO stands for first in, first out, and means that the data written into the buffer first come out of its first. There are other kind of buffers like the LIFO, that is last in first out, often called as a stacked memory, and the shared memory. The choice of a buffer architecture depends on the application to be solved. In computing and in system theory, FIFO is a method of organizing the manipulation of a data structure where the oldest, that is first entry or head of the queue, is proceed first. In the given diagram, the incoming arrow is an input to the FIFO and outgoing arrow is the output of the FIFO. That means first input will be appeared as a first output. FIFOs are commonly used in electronic circuits for buffering and flow control between hardware and software. In its hardware form, a FIFO primarily consists of a set of read and write pointers, storage and control logics. Storage may be static random access memory, that is SRAM, flip-flop, latches, or any other suitable form of storage. Now what is 4:4 FIFO? Let us see. 4:4 FIFO means the FIFO which has 4 memory locations with 4 bit size is known as 4:4 FIFO. That means this FIFO memory has different 4 memory locations that are 0, 1, 2 and 3 with each 4 bit size. Hence the name is 4:4 FIFO memory. Here is the block diagram of FIFO, in which it has different pinouts such as reset pin, which is used to reset the FIFO. Then data in pin, where we are going to give the input to the FIFO. Then write and read pins. Then clock pin, where we are giving the clock signal. Next is the data out pin, where we are getting the output of the FIFO. Next, empty pin. Empty pin will be indicate that the memory of FIFO is empty. After that, the full pin will indicate that the memory of FIFO is full. A FIFO buffer is a read or write memory array that automatically keep track of the order in which data enter into the module and read the data out in the same order. In hardware, FIFO buffer is used for synchronization purposes. It is often implemented as a circular queue and has 2 pointers, read pointer and read address pointer, or write pointer and write address register. Read and write address are initially both at the first memory location and the FIFO queue is empty. When the difference between the read address and write address of the FIFO buffer is equal to the size of the memory array, then the FIFO queue is full. VHDL code for 4:4 FIFO. Now first of all we will see what is an VHDL code. VHDL stands for Very High Speed Integrated Circuit Hardware Description Language. It is a programming language used to model a digital system by data flow, behavioral and structural style of modeling. This language was first introduced in 1981 for the Department of Defense, that is DoD, under the VHSIC program. In VHDL, an entity is used to describe a hardware module. An entity can be described using entity declaration, architecture, configuration, package declaration, package body. Now let's see what are these. Entity declaration. It defines the name, that is input output signal and module of a hardware module. Architecture. Architecture can be described using structural, data flow, behavioral or mixed style. In that, data flow modeling. In this type of modeling, the flow of data through the entity is expressed using concurrent, that is parallel signal. The concurrent statement in VHDL are when and generate. Behavioral modeling. In this type of modeling, the behavior of an entity as set of statements is executed sequentially in the specified order. Only statements placed inside a process, function or procedure are sequential. In structural modeling, an entity is described as a set of interconnected components. A component's instantiation statement is a concurrent statement. VHDL has been standardized by the Institute of Electrical and Electronic Engineers, that is IEEE standard 1076. The file name extension for VHDL is .vhd. The key advantages of VHDL when used for system design is that it allows the behavior of the required system to be described and verified before synthesis tool translate the design into real hardware. Another benefit is that VHDL allows the description of a concurrent system. VHDL is a data flow language in which every statement is considered for execution simultaneously. Unlike procedural computing language such as BASIC, C and assembly code, where a sequence of statements is run sequentially, one structure at a time. A VHDL project is portable, being created for one element base. A computing device project can be ported on another element base, for example VLSI with various technology. A big advantage of VHDL compared to original Verilog is that VHDL has a full type system. Designers can use the type system to write much more structured code. Here we have written some part of our VHDL code in which we have declared the standard logics to the pinouts of our FIFO. In that, architectural behavior of FIFO memory is component write pointer, read pointer, memory array and status signal, etc. Out of which FIFO threshold, FIFO overflow, FIFO underflow are the main components. What are these components? Let us see. FIFO threshold. The FIFO threshold level determines when the data in the FIFO should be transferred to or from memory. There are 4 configurable threshold levels per stream starting from 1/4 FIFO full to FIFO full. The read port has its associate memory addressing logic called as read pointer logic, and write port has write pointer logic. When FIFO is reset, both read and write pointers are point to first memory location of the FIFO. As and when data is returned to FIFO, write pointer gets incremented and point to next memory location. Similarly, when read operation takes place, read pointer gets incremented for every read. Both pointers work in circular fashion, that is, after reaching the last position, it will jump to first location of the FIFO. Full flag and empty flag are used to detect the status of the FIFO. These two flags are generated depending on the comparison result of FIFO pointers. Full flag is asserted when FIFO is completely full. Empty flag is asserted when FIFO is empty. Assertion of full flag indicates that no data can be read or written further unless at least one data is read out of the FIFO. Assertion for empty flag indicates that the condition that no more data can be read from the FIFO unless until at least one data is returned to the FIFO. Even after the assertion of full flag, if data is returned to FIFO, overflow condition occurs. Similarly, after the assertion of empty flag, if read operation is performed, then underflow occurs. Either overflow or underflow condition causes the data corruption or data loss. Safe and reliable FIFO design always avoid both extreme conditions. Test bench of VHDL code. Now what is this test bench? Let us see. VHDL test bench is important part of VHDL design to check the functionality of design through simulation waveform. Test bench provides stimulus for design under test duct or unit under test UUT to check the output result. A test bench is a HDL code that allows us to provide a documented repeatable set of stimuli that is portable across different simulators. Test bench consists of entity without any IO ports, design instantiate as components, clock inputs and various stimulus input. RTL schematics. What is RTL schematic? In digital circuit designs, register transfer level, that is RTL, is a design abstraction which models a synchronous digital circuit in terms of the following flow of digital signal, that is data, between hardware register and the logical operations performed on those signals. Register transfer level abstraction is used in hardware description language, that is HDLs, like Verilog and VHDL, to create high level representation of circuit from which lower level representation and ultimately actual wiring can be derived. Design at the RTL level is typically practical in modern digital design. This is the RTL schematic for the FIFO memory. Output of our code. This is the output which is shown by the waveforms. Courses outcome. By developing this type of application, we are able to understand the FIFO memory and develop 4:4 FIFO. Also, the working of 4:4 FIFO we have understand. We have developed an VHDL code and test bench code for 4:4 FIFO. Also, we have understand simulation using Xilinx ISE design and able to implement program based on application. Conclusion. Hence, we have developed VHDL code and test bench code for 4:4 FIFO memory. Also, we have understand the working principle of FIFO memory and we learned how to do simulation on Xilinx software. References. Reference books, textbooks, internets, guidance from our teacher are the references used to complete this project. Thank you.
Zeal Education Society, redefining excellence.